So I'm going to talk about what happens to the indices of a series when you take the derivative today. So we're going to start with just a general power series centered at 0, and I've already written this one out, and we call it y. And so we'll see a general power series, oops, I wanted my highlighter, starting at 0 gives me a constant because you plug in x to the 0. So what we're going to do is we're going to take the derivative of this power series to see what happens, and we're allowed to take the derivative in general using the series notation, but we can also, this is how we find out what happens to the indices, the bottom index mostly, is by taking the derivative term by term, and that's why I wrote it out. And as you can see, I wrote out n equals 0 as the first term, a0, the constant, and I wrote out about 3 terms, but the series goes on. So we get a to the n times n, x to the n minus 1, and we know it's going to infinity. Let's hold off and see what happens here. And when I take the derivative term by term, we have a constant, I get 0, a1 plus 2a2x plus 3a3x squared. And what happens here? This is my n equals 0. We came to 0. N equals 1. N equals 2. And you see it matches the index. And what's happening? The first term dropped off, so we are going to have to increase this index starting at n equals 1. We start it here, and so both sides equal to each other. And it's good. Let's do it again, just to make sure. Y double prime equals a to the n, n times n minus 1, and we go down by 1. And just a scooch over here. So, of course, there's no term there to take a derivative of, but we're taking the derivative here, and that was our n equals 1. And our 0, 1 did drop off a while ago, last time. And here I get 2a2 plus 3 times 2a to the third x, and it goes on. So we can see our first counter, n equals 1, did drop off because it was a constant, and I get n equals 2 is my second. So that's where I'm going to start this series at n equals 2. So what's happening is when you have a constant, it's dropping off to 0, and so it drops off, and we can move the series to the right one and add 1 to the counter. So the question, though, is, does it always go up by 1 because you're taking the derivative? Is that the general? I don't think so, but let's take a look. So let's start. Again, we're not always so lucky to have just a pretty general power series. What if we have, we'll keep it simple though, a power series, but starting at n equals 1 to infinity. So what I've done here is when I've created a power series that doesn't have a constant to start with. And we can always tell if it has a constant by just plugging in your first counter to see what the power of the x is. We can see it's x equals 1, not 0, so it's not a constant. But let's write it out and take the series derivative term by term. So we get a1x1 plus a2x2 plus a3x3, and that goes on. And I want to take y prime, and I get a to the n, n times n minus 1, and it goes to infinity. We'll wait on our lower index. When I take the derivative of this first term is just plain old a1. Did not drop off, as you can see. 2a2x plus 3a3x squared going on. And let's see, this is n equals 1, just like this was n equals 1. And so what's my new counter here? It's still n equals 1. That did not go up by 1. And again, it didn't go up by 1 because there is no constant to drop off. So I think that's our rule. Let's go ahead and take a second derivative just to make sure we're going in the right direction. So it's a to the n times n x to the, whoops, got to pull down that n minus 1, take the derivative in general, x to the n minus 2. And we do have this first term turns to 0. That's my n equals 1 term. We took the derivative, turns to 0, plus 2a2 plus 3 times 2a to the 3x. And by the way, I'm not multiplying these because if you do, and you're looking to write it in closed form, if you're going from this right side trying to write it into closed form, if there's a factorial or you need to look at the patterns, I always suggest not multiplying it out so you can see the pattern better. It's easier to write in closed form when you don't multiply it out. So yeah, this dropped off, the constant dropped off, and so we do start our second counter at n equals 2. It does increase by 1. So there you have it. Pretty much, if you're taking a derivative of a series, you only increase the counter by 1 if it starts with a constant. So what if I want to take the integral? Let's do in general. And let's go ahead and write it out. We're going to do n equals 0 to infinity. And we'll write it out. A naught plus a1 x1 plus a2 x squared plus, that's probably enough. And I want to integrate both sides. And we'll do it term by term on the right. And when I integrate, I can do it in general. So I add 1, divide by that value, and over here I get a naught x plus a1 x squared over over 2, sorry, just the constant, plus a2 x to the third over 3, and that's going on. And so let's evaluate. This was my n equals 0. This is still my n equals 0. This is my n equals 1. And so it looks like nothing happens. We don't increase or decrease. And it works out. And that's the end. Thanks for watching.